Okay, in geometry, you've used a lot of sine, cosine, and tangent for right triangles. And all of our angles have been less than 90 degrees. Well, what happens if we have something that's more than 90 degrees? That's what we're going to see in a couple of our examples, where we are going to evaluate. We are going to evaluate different trig functions of different angles, all on our coordinate plane. So just, again, a little bit of a refresher here. On our coordinate plane, we start off on the positive x-axis. So we always start at the positive x-axis. This is 0 degrees. If we make it all the way around the circle, all the way around the coordinate plane, it's like making it all the way around a circle, we also could call it 360 degrees. We always go counterclockwise. We always go counterclockwise around our coordinate plane. This would be 90 degrees. Over here is 180 degrees. Down here is 270 degrees. And all of our other angles can fit somewhere in between. As far as quadrants go, remember that we always start in our positives. This is quadrant 1 up here in the top right corner. And just like our angles, we go counterclockwise. So quadrant 2, quadrant 3, and quadrant 4. It definitely doesn't hurt to remember your quadrants. I think one of the more recent ACT practice tests that I have taken, there was a question about quadrants. So that's a good thing to remember anyway, where your quadrants are. Okay, now remembering this, let's evaluate for problem 1 here. Let's evaluate the cotangent of 330 degrees. In order to evaluate this cotangent of 330 degrees, what we want to do is visualize where this angle is going to be on our coordinate plane. Well, if we're talking 330 degrees, we always start off on our positive x-axis. We always start here. And we want to figure out if I have a line that's drawn, if I have a line that's making a 330 degree angle, what is it going to look like? Well, if I go 330 degrees, I'm going to be pretty close to here. Well, how far is 330 degrees away from 360? It's 30 degrees. So we are making really a 30, 60, 90 right triangle. Okay, so when we draw in our angle, we always want to think about how far am I going from the positive x-axis. Once I have this angle drawn in, then we draw a vertical line to the x-axis. In doing so, again, we make our 30, 60, 90 right triangle. All right, now let's think about if I have a 30, 60, 90 right triangle, what are the lengths of my triangle going to be? Well, opposite my 30-degree angle, this side is 1. Opposite my hypotenuse is 2. Opposite my 60-degree angle is the square root of 3. This is where those special right triangles earlier came in. The one thing, or I guess the biggest thing you need to be careful about is the signs, positives and negatives. Since I'm in the 4th quadrant, if I think of this point here, my x value is positive, but my y value is negative. So I need to really think of this as it's a negative 1. Okay, cotangent. Now that I have my triangle drawn in, think of what cotangent is. Cotangent, that's one of our reciprocal functions. cotangent is paired with tangent. And if I know tangent is opposite over adjacent, cotangent's the reciprocal, cotangent is adjacent over opposite. So in this case, our adjacent leg, look at the angle that you're making with the x-axis. So look in here. Our adjacent leg is the square root of 3. Our opposite is the -1. The square root of 3 over -1 is negative square root of 3. So the cotangent, 330 degrees, is the negative square root of 3.